Today, let's explore how mathematics and cognition may be isomorphic to each other. To construct this, we will employ process metaphysics. We will show that we can unify mathematics and cognitive science through a single operational principle. This process-oriented view can bridge the gap between abstract numbers and the dynamics of the human mind. The core problem is the unbridgeable gap between static, eternal mathematical objects and dynamic, temporal cognitive processes. Mathematics is traditionally seen as a realm of perfect, static objects, while human cognition is an ongoing, fluid, temporal activity. Physicist Nicholas Giesen proposes using intuitionist mathematics to describe physical reality. Giesen proposes that a number is not a static object, but an ongoing, unfolding activity. Stability in mathematics emerges through iteration of natural random processes, fundamentally viewing numbers as processes. In digital electronics, a single component, NAND or NOR, can be replicated and composed to build everything. Continuous mathematics, however, relies on a bloated vocabulary of primitives. Does continuous math also have a minimal generative basis? The discovery is the exp minus log, or EML operator. Physicist Andrei Odrevolek proved that this single binary operator, paired with the constant 1, can generate the entire standard repertoire of elementary mathematics. In his generative approach, mathematics can be viewed as a binary tree, where every operation is a structural branching of identical EML nodes. This forms a complete topology of standard mathematical operations generated from this one primitive. In the realm of mind, Quaternion process theory of cognition argues that thoughts are not static objects. Cognitive contents are ongoing standing waves or continuous loops described by their intensity and phase. If math is built from one process operator and mind is a process, we hypothesize a single cognitive operator to generate all the kinds of cognitive processes. This is QML, the generator of all cognitive composition. This mirrors the structure of EML. This mapping between EML in mathematics and QML in cognition is an exact structural isomorphism. The architecture of mathematics and cognition are the same algebraic structure, twice instantiated as a process algebra. Surprisingly, this method generates a Rosetta Stone of process algebra that reveals the structural correspondence between mathematical concepts in EML and cognitive concepts in QML, including the universal generator, the fold, and the unfold functions. Just as EML revealed a generation depth in mathematics, QML reveals cognitive depth. As an example, it reveals the cognitive asymmetry principle, reveals that abstracting away from felt experience takes one step, but reconnecting an abstraction back to felt experience is fundamentally harder, requiring multiple nested steps. Another curious mapping is cognitive arithmetic. Addition is the synthesis of explicitly structured concepts, or mediation. Cognitive differentiation, or subtraction, is finding the exact distinct difference remaining between concepts. We have analogs of cognition to mathematical operations. Multiplication synthesizes down into pure quality, or firstness, operating on parallel loop composition. Addition synthesizes up into mediation, or thirdness. They are inverses in their direction of composition.
The imaginary unit way in mathematics, or the square root of -1, is cognitively understood as the rotational operator that rotates perspective across cognitive quadrants. It enables access to the full cognitive space. Wheeler's identity represents cognitive completeness. Unfolding a rotation starting from the antiground returns precisely to the ground, leaving zero cognitive residue. The aha moment is this cognitive residue dropping to zero. There are some counterintuitive results of this mapping between EML and QML. Consequence 1. Multiplication is primitive. While standard intuition teaches addition first, process algebra suggests multiplication is cognitively deeper, operating at the level of pure quality. Teaching multiplication through felt quality may accelerate mathematical development. Consequence 2. Division by zero is trauma. The true void has no quality to fold to, causing the cognitive operation to crash. Therapy provides a non-zero ground, or minimal stable identity, to prevent processing the true void. Consequence 3. Forgetting is folding. Forgetting is not losing data, but folding layers of self-reference until only pure quality remains. The structure is folded, not gone. Memories can be recovered by providing structural scaffolding to allow the quality to unfold.
Consequence 4. Calculus is native to mind. Differentiation is temporal tracking, noticing change, while integration is accumulation over time, or memory. Mathematical difficulty is primarily notational, not conceptual. Consequence 5. The cognitive Fourier transform. All thought is composite. There is no single location for a thought. A thought is a frequency profile distributed across all active loops. The search for a single location for a thought is misguided. This synthesis of treating numbers as processes and the generative function as a shared structure of any process, either math or cognition, leads to a surprisingly informative model of cognition. If you like this kind of provocative thinking, please subscribe to my channel and smash that notify button. Thank you for watching this video on process monism and its consequences.